Hello students, last class we discussed about p-type material. If you want to make p-type material, you need to add trivalent impurity with the intrinsic semiconductor so that each trivalent impurity provides one hole, so it is more positive. Hole means it is ready to accept the electron, so your p-type material, the majority carriers are holes. So in this lecture, I am going to explain how to prepare n-type semiconductor. So take a pure silicon. Pure silicon means it is an intrinsic semiconductor, and now you add an pentavalent impurity with the pure silicon. So this arsenic is one of the pentavalent impurity. Why it is called pentavalent impurity? Because in their valence band it has 5 electrons. 1, 2, 3, 4, 5. It has 5 electrons in their valence band. That's why it is known as pentavalent impurity. Now add a pentavalent impurity with the pure silicon. So this process is known as doping. Doping means adding impurity with the pure silicon. Now because of that chemical reaction, this silicon will be chemically reacted with this arsenic and it will share their valence band electron to attain a stability. So here the silicon atoms will be share their valence band electrons, it reaches the stability, but now there is an excess of electrons here. So here 2, 4, 6, 8. So there are 8 electrons in their valence band. Apart from these 8 electrons, we have excess of electrons. One more electron in this particular combination. So this is an excess of electrons. So now the neutral state or stability of an atom is affected. When the atom becomes stable, when number of electron equal to number of proton mean, then the atom is said to be a neutral atom. If the number of electron is lesser than the number of proton mean, then the atom is said to be a positively charged. But here there is an excess of electrons. If there is an excess of electron means this combination is negatively charged. So here also the stability of an atom is affected. So because there is an excess of electron, so this combination behaves as a negative ion. So that is an impurity level. Now look at the impurity level or doping level, and generally one impurity atom is added to 10 power 8 atoms of semiconductor. It means silicon. The purpose of adding impurity in the semiconductor to make it conductive, you know very well about that. And each pentavalent impurity atom provides one electron, one excess of electron in the semiconductor crystal. So here I have mentioned the silicon crystal. As an extremely small amount of pentavalent impurity has a large number of atoms. It means that take 1 milligram of pentavalent impurity, that 1 milligram of atom contains million and millions of atoms. That 1 milligram contains million and millions of impurities. Each impurity provides 1 electron. So you will get million and millions of electrons in the semiconductor. So this is take a pure semiconductor or intrinsic semiconductor, add 1 pentavalent impurity, it will provide 1 electron. If I add another impurity, it will provide another electron. Like this, we are adding so many million and millions of pentavalent impurity with the pure intrinsic semiconductor. Finally, this intrinsic material is negatively charged, or this intrinsic material has more number of electron compared to positive ion, or more compared to proton. So it means that it is negatively charged. So each pentavalent impurity atom creates 1 electron. The majority carriers are electrons in n-type material. Majority carry means here the number of electron is high when compared to holes. That's why it is majority carriers. Okay, we will discuss about that PN junction in the next class, and before that I would like to give an introduction about that PN junction. Take a p-type material and n-type material and join together. So p-type and n-type meeting together at this point or junction, it is known as PN junction. The remaining thing we will discuss in next class. Thank you.